Claude just built a perfect three-statement financial model from scratch. The statements line up, every formula works. If you haven't seen it, go watch Tim Vipon's video at CFI. It's incredible. At this point, Claude is genuinely a miracle tool for building financial models. But building the model is only half the job. The other half, the part that actually takes most of the time, is processing the raw transaction data that feeds those models. The question is, can Cloud actually handle that part of the workflow? Here is what we are working with: 5 real files from 2 people, Jack and Jill. Let me show you why this is harder than it looks. Jack's checking account, no headers at all, just 4 columns of raw data: a date, an amount, a blank column that's supposed to be check numbers, and the description. If you open this in Excel, you wouldn't even know how to map the fields without inspecting the rows. Jack's credit card, this one has headers, 5 columns, transaction date, description, amount, and a type column that flags balance payments. Completely different schema from his own checking account. Jill's checking account, 3 columns with headers, but the date column is just called date. Jack's credit card calls it transaction date. Same information, different labels. And then there's Jill's credit card. This is the messy one. It has junk rows, a beginning balance row, a running balance totals, credit card payment entries that aren't real transactions. You'd have to strip those rows out before the data is even usable. Finally, the Amazon order history. This has product names, individual costs with tax allocated to each item, and dates recorded down to the minute, not just the day. And here's the real problem: Amazon doesn't charge your credit card once per order. It splits orders into arbitrary groups of charges. One order with 4 items might show up as 2 or 3 separate charges on your credit card, and the groupings have no obvious pattern. So 5 files, 143 individual transactions, no consistent format, and a matching problem that honestly is very hard to solve reliably in Excel. So let's see how Claude handles it. A couple weeks ago, we created this financial automation pipeline for reconciliation of personal finance data, and the results turned out quite satisfactory. So it would load and clean the data, and it would merge data from different data sets, and then it would combine vendor data from Amazon with payment data from sources like checking account or credit card statements. And it would unpack those payments into individual product purchases. So when it worked, we would precisely get 143 entries. This time, I'm going to get Claude to achieve the same thing. I'm going to give Claude all 5 files and the real world prompt. I already prepared a prompt here, which basically says, these are my CSV files, and load all of them and do some filtering. So clean the odd rows and junk rows so that data is workable, and create a merged view from these data sets. So that's where I'm stopping the prompt, just to keep it simple and observe what it actually accomplishes with this. So let's run it. We started with 92 entries across 4 accounts in Jack's checking account, Jack's credit card, Jill's checking account, and Jill's credit card. So Jill's checking account only has 3 entries with headers, and Jack's checking account only has 4, but no headers, and the dates seem like they need some formatting. Then Jack's credit card entries, we have around 21, and one of them, this mobile payment, shouldn't satisfy the filter and shouldn't qualify. And we have Jill's credit card, which is the messy one with all of these entries. We have here precisely 64 entries, -2, so it should be 62. Let's see what Claude is doing. It read the sheets successfully, which is good. So that's going to be the context for the LLM, and it's cleaned and standardized them and prepared for combining the data set. It's verified the headers, which is good. It did some cleaning. It did some date formatting, which is also very good to see. This looks impressive, actually. And it fixed date formatting on all cleaned sheets. Okay, we'll see what the results will be of that. And okay, that's very good to see. So one from Jack's side, one item doesn't qualify, and then we have these 2 entries that don't qualify from Jill's credit card. So 92 total minus those 3 will be 89 items, which is really, really good at this point. Claude is performing quite well. There was an issue with converting the date. So obviously we have US format and UK, Europe. A lot of places format dates differently. So US is month, day, year, and then UK is day, month, year. Okay, it's working with those anomalies and seems to be doing a very good job. So it even fixed this US format into UK format, which is the locale I'm using on this computer, and all dates are fixed. Okay, it looks perfect. Stopping here as requested. So when I come to this sheet called pre-combined data, I get 89 entries, which is good. It worked. We have those from Jack's checking account, Jack's credit card, which is 20 items, 3 from Jill's checking account, and then we have the Jill's credit card, 62. Perfect. So, first round, success. Let's continue with the next round. So, on the cleaning and consolidation steps, Claude gave us superb performance. And honestly, from what I've seen so far, this is where LLMs can be surprisingly good. But the interesting part comes next. Now, I'm going to give Claude the problem that actually makes this dataset difficult. Amazon doesn't charge your card once per order, it groups products into arbitrary charges. So if Jill ordered 4 products on Amazon, she might see a single charge on her credit card, and those amounts don't correspond to any single item. What you're really dealing with here is an allocation problem. You need to take the products from each Amazon order and figure out which combinations of items could explain each credit card charge. This becomes a combinatorial search problem. You're effectively testing every possible grouping of products against each charge amount, at least if you want to do it properly. So I have my prompt here, and I'm going to get Claude to do this part of the task. So I created a pretty explicit prompt so that it reads the data sources, and then it's going to reconcile with Amazon payments. And I also specifically instructed Claude to preserve all original data and only replace matched Amazon payments. Let's see how it performs. I'm using Opus 4.6 from the Cloud Exaladdin. I think it's going to do some thinking here. So first it's reading the data, and the Python logic for reconciliation is going to take place here because it needs to strategize about what logic to approach this with. I'm genuinely curious how it will perform for this specific task. Okay. I quite like that you can see what's going on under the hood. So it's showing the actual Python code it came up with. So it's not a black box, and we're not completely blind about the process that's taking place. It seems like quite a few loop iterations are taking place, and then um, it's matching to those values to 1 cent range for difference. Okay, let's see what's happening here. It says good progress. We went from 12 to 11 unmatched. I don't know if it sounds like a progress. Some of these remaining ones likely require larger combinations. We're down from 11 to 7 unmatched. Oh, okay, sorry. So 7 unmatched, that sounds somewhat reasonable actually. So a positive thing is it's giving this problem the weight that it requires. It's not a very straightforward implementation, and it's iterating properly. So that's a good sign. But I'm going to need 143 entries total after the matching takes place. So that's quite important because that's quite important because if this task is not reliable, then let's say as a finance professional, I'll probably have to do the whole thing manually, um, because debugging this will probably take me longer anyway. But okay, it just finished. All original data is preserved. Non-Amazon transactions are unchanged as instructed, but it's a bit more unmatched payments, a total of 7, than I needed. So 134 entries are, let's say, 6 plus 3, something like 9 items, or 8. Yeah, 9 items are missing from this list. I don't know. That's not going to be completely useful. I like that it kept the orders, but I think maybe the prompt can be improved, but it would be good if it showed which ones of these are coming from Jill's credit cards originally, and which ones are the matched ones from Jill's credit card and Amazon products. So it's not showing those. That would be quite helpful actually. Also, I like that the descriptions haven't changed. So that's an important point. With AI, sometimes it can be editorial and take initiative to edit these these entries, but it doesn't seem like it changed any of them, which is good. Okay. So I would say Claude didn't handle this case fully successfully. It didn't map all products to all charges. But this is genuinely a difficult problem for automation, and potentially the prompt could be improved to get Claude to execute this completely and successfully. In my experience, problems like this usually require systematic code rather than just a chat interface, especially in finance, where you need to rely on those final results. So, stepping back for a second, I think this shows something important. Claude is extremely good at structured work. Give it a template, clear assumptions, a defined output, and it performs really well. Tim Vipon's model test also showed that. But raw financial data is a different kind of problem. You're not starting from a clean template, you're starting with messy inputs, missing headers, different formats, extra rows that don't belong. And sometimes you run into problems like the Amazon example. One order turns into several charges, and now you're testing different combinations just to explain a single transaction. That's where most of the work usually is in finance. The model itself isn't the hard part. The hard part is getting the data into a shape you can trust. But once that part is handled properly, everything else gets much easier. And that's where combining AI with systematic code becomes really powerful. So, how do you get reliable results? At least the way I approach it is to structure the workflow through controlled rails. You introduce AI deliberately inside a pipeline. This pipeline does everything we just asked Cloud to do, but in deterministic stages. It identifies each file type, standardizes the data, strips out the junk rows, and then runs a custom matching algorithm for the Amazon problem. It evaluates every possible combination of products that could explain each credit card charge. Systematic, exhaustive, and no guessing. Then it classifies every transaction using AI, but the model can only return categories from a predefined list. It literally cannot produce anything outside that list. 133 transactions go to the API simultaneously. The remaining 10 are familiar vendors the system already recognizes. Those get labeled locally without even calling the model. The whole thing takes like 6 seconds. 143 transactions in, 143 transactions out. Everyone cleaned, matched, and categorized. Over 1,000 runs so far, and we experienced zero hallucinations. Not because the AI is smarter, it's the same LLM model. The difference is that Python constrains the output, verifies each step, and catches errors before they propagate into the analysis. Cloud is amazing at building financial models. At this point, that much is clear. But when it comes to processing the messy real world data that feeds those models, you still need a layer of control. That's what Python gives you. If you want to see the full pipeline run end to end, raw bank files to finished analysis in 31 seconds, there's a link in description. And if you're a finance professional who's been curious about Python but hasn't started yet, this is the use case that should convince you. Not building models from scratch, Cloud already does that, but making sure the inputs going into those models are actually reliable.